Welcome to Learning with Philemon. In this video, we will be looking at ionic bonding. In the previous videos, we have been looking at how non-metal elements bond with each other by sharing a pair of electrons. Ionic bonding is classified as the bonding between metal and non-metal elements. Instead of sharing electrons, electrons are transferred from the metal to the non-metal. Let's consider the example of the ionic compound lithium fluoride. Lithium has an atomic number of 3, so it has 3 electrons. 2 electrons occupy the first energy level, and 1 electron occupies the second energy level. Watch the electronic structure video for more on how electrons are arranged in energy levels. Elements react in order to fill their outer energy level, which leads to the most energetically stable configuration. For lithium to fill its second shell, it would need to gain 7 electrons. Instead, it loses 1 electron. As a result, the second energy level is empty, so its outermost level is level 1 and is full with 2 electrons. Because lithium has lost an electron, a negative particle, now it has a charge of 1+. The charge is displayed on the top right outside the brackets. The lithium atom has become an ion, a charged atom. As it is a positive ion, it is called a cation. To determine the charge of an ion, you can subtract the number of electrons by the number of protons. The lithium ion has 3 protons, positive particles, and 2 electrons. So the charge is 3 minus 2. 1+. Notice that when saying the charge of an ion, you must first say the number, 1, and then the sign, plus. Fluorine has an atomic number of 9, so it has 9 electrons. 2 electrons occupy the first energy level, and 7 electrons occupy the second energy level. To fill its outer shell, fluorine gains 1 electron. Note that this electron is gained from lithium. Because fluorine has gained an electron, a negative particle, now it has a charge of 1-. As it is a negative ion, it is called an anion. The electrons of lithium and fluorine are depicted with different symbols, dots and crosses, to make it clear where the electron is coming from in the transfer. When asked to draw a diagram to show the bonding of ionic compounds, you should draw this diagram. Remember to always include the brackets and the charge of each ion. To recap, in the process, lithium transfers an electron to fluorine, forming a positive and a negative ion. There is an attraction between the positive and negative ions, opposites attract, so they bond together. Watch the Properties of Ionic Compounds video for more information on the structure. We have formed the compound lithium fluoride with the formula LiF. Because both ions have the same magnitude of charge, there's a 1-to-1 ratio of both in the formula. In the next slides, we will see examples where this is not the case. Another example of an ionic compound is beryllium fluoride. Beryllium has 4 electrons, so it has 2 electrons in the first energy level and 2 electrons in the second energy level. Beryllium therefore loses 2 electrons to have a full outer shell of 2. It forms a cation with a charge of 2+. Each fluorine atom receives 1 electron, forming 2 fluoride ions. If you took a sample of beryllium fluoride, there would be 2 fluoride ions for every beryllium ion. The ratio between the ions is 1-to-2. You need 2 fluorine atoms to receive the electrons from every beryllium atom. So the formula is BeF2. The diagram is similar to the previous slide, but a 2 times has been added to show that 2 fluoride ions are present. You could also draw the fluoride ion twice. Let's look at some examples without drawing the dot and cross diagrams. You can figure out the formula of an ionic compound simply by determining the charge of the ions present. Instead of drawing out the electron configuration of each element, you can find the charge of the ion using the periodic table. For example, magnesium forms a 2+ ion. This is because magnesium is in group 2 of the periodic table. Therefore, it has 2 electrons in its outer shell. It loses these 2 electrons to form a more stable configuration. Oxygen is in group 6 or 16 and therefore has 6 electrons in its outer shell. It is easier for oxygen to gain 2 electrons than lose 6 electrons to fill its outer shell, so it forms a 2- ion. Therefore, magnesium loses 2 electrons that are gained by oxygen. As the charge of the ions is the same, there is a 1-to-1 ratio of the elements. The formula is MgO, magnesium oxide. Let's look at another example. Aluminium is in group 3 or 13 and therefore has 3 electrons in its outer shell. Aluminium loses 3 electrons, forming a 3+ ion. Chlorine is in group 7 or 17 and therefore has 7 electrons in its outer shell. It gains an electron, like fluorine, to form a 1- ion. Because aluminium loses 3 electrons, you need 3 chlorine atoms to receive those electrons. There is a 1-to-3 ratio, so the formula is AlCl3. A trick to write the correct formula is that the charge of one ion becomes the subscript of the other. The 3 of the aluminium goes to the chlorine, and the 1 of the chlorine goes to the aluminium. If the 2 charges are the same, 2 and 2, as is the case in magnesium oxide, they cancel out. The naming of ionic compounds follows some specific rules. The metal or cation goes first without any change to the name, followed by the nonmetal. The name of the nonmetal is changed slightly. The ending changes to "ide." Oxygen becomes oxide, and chlorine becomes chloride. The periodic table is a useful tool to figure out the charges of the ions. Here we see an annotated section of the periodic table on the ChemLibreTex's website. Check the description for the link. Group 1 elements form 1+ ions, Group 2 elements form 2+ ions, and Group 3 elements form 3+ ions. Group 5 elements form 3- ions, Group 6 elements form 2- ions, and Group 7 elements form 1- ions. However, you will encounter ions that consist of more than one element. You cannot figure out the charge of the ion using the periodic table. Therefore, you should memorize these ions. We have the hydroxide ion, OH1-, the nitrate ion, NO3 1-, the carbonate ion, CO3 2-, the sulfate ion, SO4 2-, and the ammonium ion, NH4 1+. Care needs to be taken when writing the formula of these compounds. If there is more than one ion present, the subscript needs to be written outside a parenthesis. For example, in aluminium nitrate, there are 3 nitrate ions per aluminium ion. NO3 is written in the parentheses with a 3 outside. Similarly, the formula of ammonium sulfate is NH42SO4. If the ratio is 1-to-1, like in magnesium sulfate, there is no need to include a parenthesis. Note that sulfide and sulfate are not the same ion. Sulfide consists only of the element sulfur, whereas sulfate consists of sulfur and 4 oxygen atoms. To summarize, ionic bonding occurs between metal and nonmetal elements and involves the transfer of electrons. A cation is a positive ion and an anion is a negative ion. The ratio of the ions in the chemical formula depends on the charge of the ions. When naming ionic compounds, the nonmetal name changes to "ide" or 8 if oxygen atoms are also present. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.